Today we're going to talk more about the normal distribution. We've already discussed it a bit with the 68, 95, 99.7 rule. It says, as we begin to create a better picture of the way data are dispersed, we realize that in many instances, the shape of the data falls into one of a few recognizable forms. For instance, if we took a large sample of men's heights, a histogram built with the data would look approximately symmetrical and bell-shaped. With a large enough sample, our histogram would become what we call the normal distribution. A normal distribution is bell-shaped, meaning it has only one mode at the center, and it's symmetrical. The mean, median, and mode are all the same, or in a sample, approximately the same. The total area under the curve is equal to 1. 100% of the data falls beneath the curve. It's completely defined by its mean and standard deviation. So when we talked about the 68, 95, 99.7 rule, we talked about the data being 1, 2, or 3 standard deviations from the mean. Well, unfortunately, data isn't always going to fall exactly 1, 2, or 3 standard deviations from the mean. It might be somewhere in between. So we have to use something called the z-score. And the z-score tells us how many standard deviations a particular piece of data lies from the mean. The z-score is found by taking the particular data value, subtracting the mean, and dividing by the standard deviation. So for a population, it would be x minus mu divided by sigma, and for a sample, it would be x minus x hat divided by s. Both are basically the same thing. Example 1 wants us to calculate z-scores. So given that the heights of Canadian women are normally distributed with a mean of 159.5 centimeters and a standard deviation of 1.7 centimeters, calculate the z-scores for the following pieces of data. So a height of 148.2 centimeters, we would take 148.2, subtract the mean of 159.5, and divide by the standard deviation 7.1. We get negative 11.3 divided by 7.1, or approximately 1.59. So we say that we don't really use the negative when we talk about it. We say that this data point is 1.59 standard deviations below the mean. So this person is shorter than average, basically. Okay, so a height of 160.3 centimeters, we would subtract our mean and divide by the standard deviation and get approximately 0.11. So we are 0.11 standard deviations above, since it's positive, the mean. This person is slightly taller than average. And a height of 1.7 meters, well, first of all, we got to change that to centimeters. And there's 100 centimeters in a meter, so be careful with this. Everything else is in centimeters. We got to make sure that our data value is also in centimeters. So that's 170 centimeters. Subtract the mean. Oops. divide by the standard deviation. 1.48. This person's height is 1.48 standard deviations above the mean. So definitely taller than average. Example 2. Suppose that the average caloric intake for women is 2,050 calories per day, with a standard deviation of 175 calories. If we assume that the caloric intake follows a normal distribution, find the percentage of females in your class that consume more than 2,000 calories per day. So, we first need to find the z-score. So 2,000 minus our mean, which was 2,050, divide by the standard deviation of 175, and we get negative 0.29. Now, we're trying to find the percentage of females that consume more than 2,000 calories per day. We want a percent. All we've got is the z-score. Now, if you've got a graphing calculator, you can do this on the graphing calculator. I'm going to show you how to do it in Excel because all of us have access to Excel. And I'll add on to the video here. This is the last example for this section. So I'll add on just what it looks like in Excel to the end of the video. But here's what you would type. You type norm.s.dist. Oh, D-I-S-T. So write that down. Equals norm.s.dist. Then you put in your z-score. In this case, negative 0.29. So anytime you need to find a percentile, you're going to use this right here. But in our particular case, it's negative 0.29. And then we type true, comma, true. Now, what does the true do? The true always, write this down, please, so you'll know, always reports to the left of the z-score. So it's going to report that the percentile we get is greater than everything else, okay? So what we get when we put this into Excel is 0.3859. So we'll say that 38.59% of these women consume less than, remember I said to the left, less than 2,000 calories per day. So what we've found is how many consumed less than. The problem asks us to find the percentage that consume more than 2,000 calories per day. So all we got to do to find the more than is subtract 0.3859 from 1. 0.6141, or 61.4% of females consume more than 2,000 calories per day. Okay? So here's the process again. Put this in Excel. After you've found the z-score, put that in Excel with your z-score. Realize that that's telling you the percent less than, and subtract from 1 if you need the more than. And all of this is, actually I even put that equals, that norm.s.dist in your notes there. So that's good. And pointed out that to find to the right, you subtract from 1. Okay, so let's look at this on Excel real quick. To in Excel, if we wanted to use Excel to find the z-score, that's pretty simple. So we'd say equals, parenthesis, and we had 2,000 minus 2050. We have to put the top in parentheses, so we're opening and closing there, then divided by 175. That gives us our z-score. Okay? And so to find the percentile, we type in our letters. So equals norm dot s dot dist, and I've got it in lowercase, but it doesn't matter. Excel knows what I'm talking about. And it tells you what to put in there. It says put in the z-score, so we'll select on that. Comma, and like I said, you just put true. Close parenthesis. Hit equal, and there is your percentile. Remember I said that was to the left though. So if we want to the right, then we would just say equals 1 minus, select that cell. There we go. That was our percentage to the right. 61.24% of females consume more than 2,000 calories per day. There are actually 5 additional examples that I'm going to work for section 4. So you have plenty to go on here to help you with. The first example says last year the revenue for medical equipment companies had a mean of $50 billion with a standard deviation of 11 million. Find the percentage of companies with revenue greater than $30 million. Assume the distribution is normal. So in this case, it doesn't say anything about the empirical rule. The empirical rule might work, and so we can go over to this graph and see if it does. We've got 50 was our mean, and 11 is the standard deviation, so that would take us up to 61, 72, and 83, and down to 39, 28, and 17. We want greater than $30 million, so that's about right here. It's not quite 2 standard deviations below the mean. And so we're not going to be able to use our empirical rule because it's not exactly 2 standard deviations below the mean. So what we use is the z-score. So from our notes, our z-score is the data value minus the mean over the standard deviation. Our data value here is 30, the mean is 50, and the standard deviation is 11. Gives us negative 1.818. So we are 1.818 standard deviations below the mean. To find the percentage that's greater than negative 0.818 standard deviations below the mean, the easiest way to do that is to use Excel. Now, I'm not going to go over to Excel and do this right now, but all you have to do is enter this into Excel, equals, and then for greater than, we have to do 1 minus. If you don't do 1 minus, it's going to find less than. So naturally, when we use this formula, it will naturally find less than. We have to do 1 minus to get greater. So 1 minus norm dot s dot dist. And then we plug in our z-score, negative 1.818, comma, the word true. And that tells us, as a decimal, the area to the right of that z-score is 0.9656. So as a percent, it would be 96.56% of the companies have a revenue greater than $30 million. Example 2 says what percentage of the area under the normal curve is to the left of negative 1.35 and to the right of negative 0.24. So negative 1.35 would be about here, that many standard deviations below the mean, and we want the area to the left. Negative 0.24 would be maybe right here, and we want the area from there to the right. So what we're going to do is we've already got the z-score, so we don't have to use that, but we're going to use Excel, those little formulas that we put into Excel to find each of these. So first we need to the left of negative 1.35. So to the left is just equals norm dot s dot dist negative 1.35 comma true. And that gives us 0.088508. Then we want to the right of negative 0.24. And remember, to the right, we have to put equals 1 minus, and then our norm dot s dot dist negative 0.24 comma true, and we get 0.594835. So we want the percentage to the left and to the right. So we're going to add them. So our total would be 0.088508 plus 0.594835. 0.68343. So changing that to a percent, the two decimal places would be 68.33% of the data is to the left of the first z-score and to the right of the second. Example 3 says a water bottling facility has a mean bottling rate of 32.4 thousand bottles per hour with a standard deviation, I'm going to underline here, with a standard deviation of 1.84 thousand bottles. A nearby cola bottling facility has a mean bottling rate of 27.5 thousand bottles per hour with a standard deviation of 1.46 thousand bottles. On Wednesday afternoon, from noon to 1 p.m., the water bottling facility bottles 34.3 thousand bottles of water, and the cola bottling facility bottled 29,000 bottles of cola. Which facility increased their efficiency more during that hour? So with different means and different standard deviations, it's impossible to just look at this and determine which one was more efficient during that hour. The way we do it is to look at the z-scores. And if we can see the z-scores to see which one has a standard deviation less from the mean, then that would tell us they had better efficiency. So the first one, the water bottling facility, the mean was, a data point is 34.3 minus a mean over the standard deviation, and we get a z-score of 1.0326, which we'll just round to 1.03. Then the cola bottling facility, their data point that we're looking at is 29 minus their mean of 27.5 divided by the standard deviation of 1.46, and we get 1.0274, which I'm going to round to 1.03. So what does this tell us? Well, the z-scores are the same. So they both actually increased their efficiency by the same amount. I don't think there's two N's in there. Okay? If we hadn't gotten negative z-scores, that means their efficiency had decreased, by the way. Example 4 says, use the formula for z-score to determine the missing value. So our formula for z-score, this is for population because we have mu and sigma, would be our data point minus the mean, which in this case is mu, divided by the standard deviation, sigma. So this time we're looking for mu. We have z, we have x, we're looking for the mean. So we're just solving this equation. Multiply both sides by 7.36. We have 4.7104 equals negative 23.40 minus mu. And then we're trying to get mu by itself, so add 23.40 to both sides. 28.1104 is negative mu, and we got to get rid of that negative. So we can either multiply both sides by negative 1 or divide both sides by negative 1. Either way will work. And mu ends up being negative 28.11 for the mean. And our last example says, last year the revenue for financial service companies had a mean of $70 million with a standard deviation of 18 million. Find the percentage of companies with revenue between $50 million and $90 million. Assume that the distribution is normal. So we could draw a curve here. This time I'm not going to worry about it. We want between 50 million and 90 million. Okay? So we want this amount in here. So what we can do is we can find the percent to the left, or the area to the left of the 50, and find the area to the left of 90, and subtract them to get the area in between. So, to find the area to the left of 50, we'll find the z-score, 50 minus our mean, divided by the standard deviation, is negative 1.11. And then we plug into we want to the left, so it's just equals norm.s.dist, negative 1.11, comma, true, gives us 0.1335. Then we find the z-score for the data value of 90. That's positive 1.11 equals norm.s.dist, positive 1.11, comma, true, 0.8665. So to find our area between, we'll take 0.8665 and subtract 0.1335. We get 0.7330, or as a percentage, 73.3%. So 73.3% of these companies had a revenue between $50 million and $90 million. And that's finally it for this section's extra examples.